everyone. Alright, so we are on our last video for the optical tools section. Just to recap the previous video, we went over the types of telescopes. So we have the reflecting telescopes that use mirrors and lenses in order for us to see objects that are at a great distance, like out in space. And then we have the refracting telescopes, which use convex, oh my goodness, my brain is just not here, but it's going to use lenses in order to, convex lenses, in order to help us to see things that are at a distance. Alright, so now, actually in my previous video, let me recap the question that you were asked by me. What is the function of the lenses in a reflecting telescope? So in a reflecting telescope, the lens is going to allow the eye to have the image that's being reflected off of the mirrors enlarged and sent into our eyes. So if we did not have that convex lens in the eyepiece, then we wouldn't be able to see the image. It would still be very tiny. Okay, all we would just be doing is like looking at the sky with two different mirrors. So the convex lens is in the eyepiece is going to allow the image to be magnified up to our eyes. Okay. So now we are going to go into the microscope. So microscope is going to be very similar to it's similar to the reflecting telescope. So with a microscope, first, this type of microscope is the light microscope. Okay, this is the one that is used typically in most classrooms. Its other name is a compound microscope. This is how we are able to look at images that are up close or very tiny in an up close fashion. The other type of microscope that we do not use in a classroom is an electron microscope, which really utilizes electrons to beam these super tiny particles into in a manner that we can see them a lot better. But they have to be really, really tiny, and it requires a pretty intensive machine. So for school purposes, we use these compound microscopes. So if we follow the direction of the light rays for our microscope, we see that down underneath the flat plane in the microscope is a plane mirror. This is going to gather light from outside and reflect it up into the main part of the microscope. If this mirror wasn't calibrated right, we wouldn't have light going into it, and this part where it's supposed to be shining light from the bottom up is just going to appear very dark. So this plane mirror is a very important piece for our microscope. Once it goes through or gets reflected upwards, it's going to go through this transparent piece of glass that will hold whatever specimen it is you're trying to look at. This light surrounds the specimen, shoots through it, and then the image and the light is going to go through the objective down here in our microscope. The objective is the part that has the convex lens. Okay, this is going to be a magnifying lens that allows us to see the specimen much closer. Just like with our telescope, the convex lens magnified things, made it bigger. So we got our first bit of magnification right down here in our objective lens. Then the light is going to be bent and channeled upwards through up to the eyepiece, where there is yet another convex lens that will magnify the image even further to make it to where you can see whatever this tiny little specimen is down here in your microscope. So when you're talking about microscopes, because we have two convex lenses, one down here and one down here, it's really going to magnify the image you're trying to look at. So if you're trying to see what the total magnification is, you actually you include both sizes, both the magnification for the objective and the magnification for the convex. Okay. One thing you do notice with convex lenses is they're going to bend light inwards, which is why it makes it appear much bigger as it goes upwards. And that's one thing I want you to remember. The two main properties of a microscope, those two main properties are that they will magnify images, and so there's magnification, and then there's a resolution, how sharp and how clear the images is being projected. You can have a high magnification and a very poor resolution. It's not going to be that great of a microscope. Everything's going to appear blurry. But if both of them are calibrated correctly, you're going to have a really good image. Let's see here. Is there anything else I really wanted to make sure you had? So, magnification in compound microscopes, you use multiple lenses. Remember, we have two. We have the aperture, or the objective, not the aperture. I got a camera stuck in my head. We have the objective and we have the eyepiece. These two lenses to enlarge images. The total magnification of these two lenses would be this lens multiplied by this lens to find out the total amount. So if this was 9 times and this was 2 times, the total magnification would be 18 times. Okay. And also, if you have a really good resolution, you can really distinguish between things that you're seeing on your specimen. If you can't see things very clearly, or if you can see some things but not a lot of detail, for instance, on page 68, you have the two light microscopes with the different magnifications. One's at 18 times, and you can see, you can kind of tell the things that are going on with this hair follicle, but then when you really look at it at 63, you can see the total inside workings of a hair follicle. And that's because the resolution and the magnification are just spot on. Okay? You know what? I think that's it for what I wanted to make sure you knew. So now what I want you to do is to tell me, when might you use a light microscope instead of an electron microscope? So light microscopes, we use them in school. There's certain things we'll use them for that go in here. And then think about the electron microscopes. What are electron microscopes used for? And what do they end up producing even? And so which one, when will we actually want to use a light microscope instead of an electron microscope? Okay, so answer that in the Google Classroom.